All right, everybody, welcome to our review for Unit 2. This has been a really long unit. You guys have worked really hard, and I expect great things from you on the test on Friday. Okay, remember we're going to kind of look back over square roots, cube roots, converting decimals to fractions, solving exponents using our laws of exponents, scientific notation, being able to multiply, add, divide, or subtract. But again, remember the good thing about it is you will be able to use your calculator. So let's kind of jump into our study guide. We're going to do the first part of this study guide is 1 through 10, and then I'll make another one and put it up in a little bit, be 11 through 20, and then we'll talk about 21 through 28 tomorrow during class, okay? All right, so first problem we're looking up here, we want to convert these numbers into standard notation. We're going to convert from scientific notation to standard notation. And if you look up here, remember we talked about when we're doing this, we're going to look at our exponent. Our exponent tells us two things. It tells us the direction we're going to move our decimal and the number of places that we need to move the decimal. Okay. It also tells us if it's a positive exponent, we're going to take the decimal wherever it's at, move it to the right that many places. If it's a negative exponent, we're going to move our decimal to the left that many places. Okay. So if I look at the very first problem, 7.65 times 10 to the fifth power. Well, here's my exponent. It's a positive exponent, so it tells me I'm going to move to the right 5 places. So I'm going to take my decimal, and wherever it is, I'm going to just move it to the right. Well, if I count 1, 2, well, if I look, then I need to move it a total of 5, which means I need to add 3 more decimals. I'm sorry, 3 more zeros. So let's go back and make sure if we count from here to the end, it should be 5. So from here to here is 1, 2, 3, 4, 5. So my answer is 7.65 times 10 to the fifth is actually 765,000 in standard notation. All right. Look at the next one. The next one says negative 3. So if it's a negative number, I'm going to move my decimal to the left 3 places. So if I move from behind the 1 into in front of the 1, that's 1 space. So I need to move a total of 3. So what I actually need to do is add 2 more zeros. All right. So if I look here, let's make count sure. 1, 2, 3. So my decimal is in the right place, okay? All right, so just look at your exponent. All right, here, my exponent is 7, so this is a big move. So it says I'm going to move right 7 since it's positive. Well, 1, 2, 3, 4. So if I write it out, I've already moved 1, 2, 3, 4 to get behind the 5. I need 3 more zeros. Always go back and count. 1, 2, 3, 4, 5, 6, 7. Okay, and then go back and put your commas. All right. So again, it's just looking at the exponent, let it do the work, let it tell you what to do. Well, here, this one is a positive 2. So I'm going to move it right 2 places. Well, if I move from here to here, behind the 1 to in front, front of the 1 to behind the 1, that's 1, 2. My answer is 812. All right. Well, remember, look at this one. This one is a 0. It says I'm not moving anywhere. So technically my answer is 4.3. But if you'll kind of go back over here and look at this one, you remember anything to the 0 power is 1. So remember, it's really 4.3 times 1. And as you learned a long time ago, anything times 1 is itself. Okay? So remember, that's standard form. Scientific notation into standard form. We're going to look at it the other way in just a few minutes. All right. Number 2. We've got a complex combination problem here of exponents. So we got to go back and remember our exponent rules. Well, if you'll look, the first thing that jumps out to me here is we see some kind of multiplication because we have a power raised to a power. Well, the base 2 has an exponent of 2. The x doesn't. So we're going to give it that ghost exponent of 1, and then we're going to draw our 2 rainbows. Well, remember, rainbow, power to a power means to multiply. So 2 times negative 3 is a negative 6. 1 times negative 3 is negative 3. Let me fix that. Let's kind of get rid of that. Let's redo that. X to the negative third. Have not bothered the y yet, so we're going to bring it over here. And we have not done anything to the denominator, so we're just going to bring it over here. Now, I'm going to go ahead. Now, I know a lot of you are tempted right now to move this, but I'm going to hang loose for that just for a second. I'm just going to rewrite that. 2 to the negative 6 power. And then I'm going to look at this part. Well, I have the same bases here. So my bases are x and y. Well, if I look, I'm dividing the same bases, which means I have to subtract. So a numerator minus denominator. Be very careful right here about putting this in your calculator. Remember, it's not negative 3 minus a negative 5. It's negative 3 or minus 3 minus 5. You've got to be very careful with that because some of you are doing that and you're going to end up with a 2, and I'll show you the difference here in just one second. Well, y, numerator minus denominator, okay? Well, if you think about it now, we've done it, so the denominator is gone at this present time, right? So again, I'm still going to keep 2 to the negative 6, all right? So remember, as I just said, if you'll watch, when you put in your calculator, what you're doing is you're doing negative 3, okay, minus 5. You are subtracting negative 3 minus 5. That's negative 8, okay? So you have x to the negative 8th power. So what you've got to be careful about, you have got to be very careful when you put that in, is that you don't put in negative 3 minus a negative 5. Because what that's going to do is going to be your keep flip change, and it's going to change it to a positive 2. So be very careful when you put that in your calculator, okay? All right, and then you have 8 minus 4, which is just 4. All right, so now we're almost finished. But if I look right here, sorry about that, to put that negative, I have 2 negative exponents. Remember, we can't have negative exponents. So all we're going to do is take those and put them into the denominator of my fraction and change the sign to positive, okay? Well, that makes this is gone, this is gone. All I'm left with in the numerator now is y to the 4th power. Well, I look like I'm almost finished. I don't know what y is, I don't know what x is, but I do know what 2 to the 6th power is. And remember, that means 2 times 2 times 2 times 2 times 2 times 2, right? It's just that many times, not 2 times 6, okay? So when I finish that out, what I have is y to the 4th over 64x to the 8th power. There's your final answer right there. Okay, so just remember your steps. All right, now converting this repeating decimal. Remember, guys, this is not 33. This is actually 0.333, and it keeps going on and on and on. Okay, so don't be tempted to say just because there's 2 numbers here that you're going to put it over 100. Okay, now I know for a fact that you're going to say, well, it still equals the same thing. That is 1/3, but we're going to talk about that in just a second, because I want you to look at this, because what we're doing is we're converting a repeating decimal. That's a terminating decimal, okay? So remember, we do it a little bit different. So remember, all we're doing is looking here, how many numbers are under the bar. Here's the repeating bar. There's 2 numbers. So we're going to put 2 9s, okay? And then put the number right back on top. So now I have a fraction of 33 over 99. And let's just say, if I put that in my calculator, let's just see what I have. So that's 33 divided by, oh, not 333, excuse me, 33 they still want to do it, sorry, 33 divided by 99, and look at all those 3's. Okay, so do you see the difference? If I would have put in 33 over 100, it still would have been the same, but I do want to show you the difference here in just one second. But we got to finish this out, because this is not in simplest form. So the greatest common factor for this one is 33. So we're going to divide 33 divided by 33 is 1. 99 divided by 33 is 3. Now, it just does happen that if you would have put 33 over 100, you would have gotten 1/3. But let me show you the difference. What if I put in something like 0.36 repeating? Okay, so that lets me know that I have 2 numbers under the bar. So I'm going to put 99 under here, and I put 36 here, right? Well, if I reduce this, 36 over 99, let's just say the greatest common factor would be 9 again here. So 36 divided by 9 is 4. 99 divided by 9 is 11. All right, so if we put 4 divided by 11 in our calculator, 4 divided by 11, I get 36, 36, 36, 36, 36. Okay, if you would have done it the other way, 36 over 100, you get just 0.36. Notice where it stops, okay? Because 36 repeating keeps going. 36 over 100 stops. So please be careful. Just count the number under the bar, put it over that many zeros. That many 9s. All right. The 3 types of irrational numbers we talked about were pi, ... and a non-perfect. Sorry, that's a terrible square root. non-perfect square roots. Okay, remember dot 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 is a non-terminated, non-repeating decimal. It means it doesn't stop. Okay, this would be a non-terminated, non-repeating decimal. Okay, I'm sorry, this is a repeated decimal, but see how it keeps going, 0.33. So it repeats, but it doesn't terminate. All right, so rational or irrational. If it's not one of these three, it's going to be a rational number. Well, if I look at the first one, the side length of a square that has an area of 169. So the square has an area of 169. And remember, to find the side length, we take the square root of 169. And 169 is a perfect square root. And the answer would be 13. So this one is rational. Okay? Because this is a perfect square. Well, look at the next one, 247. Remember, I can't multiply anything times itself to get 247. So this number would be a non-terminating, non-repeating decimal. This one is irrational. 3.14, if you don't see the dot 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 behind it, that's rational. Remember, this is not pi. This is sometimes used as an example for pi or a substitute for pi. But right now, this is a terminating decimal. So it's a rational number. Well, here's pi. Okay? So pi is irrational. Excuse me, irrational. And let's see if this calculator has pi on it. Well, if I was to hit pi, look at that long number. Okay, there's no pattern here, so it doesn't repeat and it doesn't stop. So this is why it's irrational. Now, see 3.14, the previous number actually stopped right here, so that's why it's rational. All right, a decimal that does terminate and does repeat, that's a rational number. The volume of a cube that has a side length of 4. Well, this is 4. Remember, volume is length times width times height. So what we're looking at here is 4 to the third power, which is 64, which is a rational number. That's a perfect cube. Okay, so we'll be looking at those numbers. All right, how many times larger? Well, remember, we talked about really quick. This is scientific notation. How many times larger is a number? When you see times larger, times farther, times anything, any kind of word behind the word times, okay, we're actually talking about, it's not a multiplication problem, this is a division problem. Okay, so what you have is 7.5 times 10 to the 8th power divided by 1.5 times 10 to the 4th power. Well, you're going to have a calculator and you're going to be able to put in, but please remember to make sure you put everything in parentheses. So when you put it in your calculator, please make sure you write it just the way we did it. Okay, so it doesn't flip it and multiply instead of divide. Well, since I don't have my calculator, I have a calculator, but it won't do it like yours will in class. I'm going to take this number. This says 7.5 divided by 1.5. So I'm going to just divide my coefficients. 7, so this goes all the way back to those exponent rules that you learned. Divide your coefficients. So 7.5 divided by 1.5 is 5. Okay, and since I am dividing, I have to subtract, right? Keep the base and subtract my exponents. Well, 8 to the 4th power, 8 minus 4 is 4. So this number is 5 times 10 to the 4th power larger. Well, I want an actual number. Okay, so let's go back all the way up to the top. Remember, the 4 says move my decimal. It's positive. Move it 4 places to the right. Well, right now the decimal is right here. I don't have anything behind it, so I've got to add, in this case, I've got to add 4 decimals. I'm sorry, 4 zeros, excuse me. Okay, so down the decimal here. So your answer in complete sentences would be 7.5 times 10 to the 8th power is 50,000 times larger than 1.5 times 10 to the 4th power. Let's see if I can type that quicker than I can write it. Probably can't. Let's just leave it at that. Okay, so it's 7.5 times 10 to the 8th is larger, 50,000 times larger than 1.5 times 10 to the 4th power. All right. So just remember, it is a division problem. Times larger, times farther, times taller, times anything makes it the division problem. You just have to set it up according to what the question asks you. And you should know this is bigger because the exponent of 8 is much bigger than the exponent of 4. Okay? All right, next page real quick. Oh my goodness, here we go. These are the ones that we have been working so hard on. And some of you are trying so hard, and I'm really proud of that. Please keep working on these because we're going to see these the rest of the year. All right, so we're going to look at some of these. Which one of these is infinite, which is 1, and which is none? Well, remember, with one solution, you're going to have different coefficients. With a no solution, you'll have the same coefficients, different constants. And then with an infinite solution, you'll have the same coefficient and same constant. So a lot of these you can actually stop a little bit short. Okay, remember the first step, get rid of these parentheses. I don't like the parentheses, so we're going to distribute this 4. So we have 8x, and then 4 times negative 5 is negative 20, plus 2x. We're going to distribute this negative 3 to the negative 6, add into the 8. So we have negative 3 times negative 6x is positive 18x, excuse me, minus 24. Well, I'm looking here, it looks kind of funny, but I'm not sure yet because I have not combined these terms. So step 1 I've already finished. Let's go step 2. We have a box. Remember, variables get boxes, circles get numbers, right? Well, I can't combine a box and a circle, but I see I have 2 boxes here. Now remember we talked about, if I was to just cover that up, if I was to read that, that says 8x plus 2x. Remember, you can't subtract anything on this side from each other. Just add them together because it says add 2 to 8, right? So what I have is 10x minus 20 is equal to 18x minus 24. Well, right now I'm looking right here. Here's my coefficient. My coefficient in front of this variable is a 10. The coefficient in front of this variable is an 18. So these are 2 different coefficients. So I know before I even do anything else, this is a one solution problem. I just need to know when is it a one solution problem. We're going to find this number right here. So to do that, we're going to keep going. Box, circle, box, circle. Well, I need to separate my variables now. So step 1 is done. Step 2 is done. Now step 3 says to separate variables on one side, numbers on the other, correct? All right, I'm going to move this small one because I like the positive variables. I like to deal with a positive variable if I can. So I'm going to move this small variable over here to the big variable. That means this is going to go away. This is 10 minus 10x minus 10x is 0 minus 20. 18x minus 10x is 8x minus 24. All right, so now I have 0 minus 20, which is negative 20, and then 8x minus 24. All right, I'm going to come right over here and rewrite this because I'm running out of room. Negative 20 equals 8x minus 24. Same thing, we're going to keep going. Here's a circle, here's a box, and here's a circle. That's a terrible box, by the way. All right, so now I've isolated my variables to the right side, which means I need to move, now I need to move my numbers to the left side. So the opposite of minus 24, and since I'm moving this, I'm going to start right up under it. We're going to move 24, okay? All right, so if I keep going right here, this is going to cross out, and I have 8x, and I have negative 20 plus 24 is 4, right? Okay, so now if I keep going, I have isolated, I have separated the variables from the boxes. All right, so the variables from the numbers. So the last step is to divide by 8. So if I cross this out, I have x is equal to 1/2. All right, so that means the only solution I have for this problem is when x is 1/2. All right, so let's go back and let's just kind of go back through this and make sure real quick. So 4 times 2 is 8. 4 times negative 5 is negative 20 plus 2x. Then negative 3 times negative 6 is a positive 18. Negative 3 times positive 8 is a negative 24. Okay, so always go back and just check, make sure you haven't missed any signs. And you can actually go back and plug this in, and we still should get the same answer on the left side as the right side. Okay? All right, let's keep going on the next one. So that's a one solution problem. Let's look at maybe see what this next one is. All right, so we're going to distribute here. Going to distribute here. Well, I can use my calculator 1/2 times 8, but I know half of 8a is 4a. Half of 12 is 6. All right, if I distribute here, I have 2 times 2 is 4a. 2 times negative 6 is negative 12. All right, well, right now, those of you that have gotten pretty good at this, you're seeing right now that my coefficients are the same, which means they're on the opposite sides, which means they would cross out, and I'm left with 6 equals negative 12, which makes that a false statement, which means right now you know that is a no solution problem. Okay, so those of you that have got that part, you keep going, and the rest of us, we're going to kind of go back here and make sure that it is a no solution problem by solving it all the way out? Well, box, circle, box, circle. Well, here, it doesn't matter since they are the same. Again, I can cross them, but I'm just going to move this to the left. So if I move this one to the left, this becomes 0 since I moved it. 0 minus 12. 4a minus 4a again crosses out, and I'm left with 6. Okay, so all I did was take one more step. Now, 6 does not equal negative 12, so I know right now this is a false statement. So I know it's a no solution problem, and I can even move this over here by adding 12 and get 18 equals 0. Well, either way, if it was false here, it's going to be false here, it's going to be false here. So once it's a no solution, it's a no solution problem all the way around. So there's not going to change. Once you figure it out, it's not going to change, okay? All right. Let's move on to the next one. The next one is a little bit longer, but let's see what it does. Well, if I combine box, well, first off, let's get rid of this parentheses first. Now, guys, right here, remember we talked about a negative sign next to the parentheses? Remember, two things you can do. Either take the opposite signs, or what you're actually doing is distributing a negative 1. Okay? So what you're going to do is distribute here and distribute here. Negative 1 times 3 is a negative 3x. Negative 1 times a negative 21 is a positive 21. So then I can combine over here, box, circle, box, circle. Well, if I combine, if I look right here, if I was to block out the circles just for a second, that just says 6x subtract 9x. Well, if I do that, 6 minus 9 is negative 3x, right? Now, if I was to box these out, that just says 5 plus 16, which is 21, right? So what I have is negative 3x plus 21. And I'm not going to go any further because now I look right here. These are the same exact equation on the left as on the right. This negative 3 cancels. That 21 cancels that one. I'm left with 0 equals 0, which is a infinite solution problem. Okay? So one solution, infinite solution, no solution. Okay? So here's the matching vocabulary part with this. So again, infinite solutions have different coefficients. Doesn't matter about the constants. And remember, the coefficients is just a number in front of x. Okay? I'm sorry, back that up. I got ahead of myself. Infinite solutions, I was on this part. Infinite solutions means it's going to be the same on both sides, just like we just had here. So you have the same coefficients and the same constants. It means the number in front of the variable is the same and the number is the same, just like we had right here. One solution is what I just did before that. Your coefficients are different. No solutions, you will have the same coefficients, but your constants will be different. Just look up here. The 4 was the same, but 6 and negative 12 are different. Okay? All right. Really quick, I'm going to do this one, and I'm going to show you how to do this one without the calculator. And I know most of you are going to say, well, it don't matter, we can use our calculator. Well, I still want you to be able to do it without the calculator. Remember, you cannot add these unless these exponents are the same. So the difference between 11 and 8 is 3. So what I've actually got to do is I've got to change this to match that. And to do that, I've got to make this 10 to the 11th power. Well, to do that, I've got to move it 3 places to the left, which means I got to go 1, and I need 2 more zeros. So 0.00. Let me move over just a little bit. And again, you're going to have your calculator, so it's not that big of a deal. 002478. So I've actually rewritten this now as that. So we come right over here, 7.6. I tell you what, let's just do it with our calculator. Now we can do this part with our calculator. Ours in our classroom will do it different, okay? All right, so I'm going to drag it over here. So what I have is 7.685 plus 0.002478 gives me 768. 7478. 768 7478. 7.68, sorry, 7478. 7478 times 10 to the 11th power. Okay, and again, your calculator will do that for you. So, and if I check real quick, this is good. One number here, and my exponents are the same, so I'm good. All right, number 9, really quick. First thing I see here, I see a coefficient, which means I need to divide and get rid of that. So 9 over 8 reduces to 1/2. All right, my other bases are m, n, and p. Well, if I'm dividing, I'm subtracting. So 7 minus 10 is -3. 3 minus 2 is 1. And 6 minus 4 is 2. Well, 1/2 m to the -3rd n to the 1st over p squared equal p squared. Right? I need to get rid of this. This is the one that needs to be changed. Negative exponents need to change. We're going to put it in the denominator. So remember what we have now is n p squared over 2m to the 3rd power. Okay? And remember again, that 1 is understood to be there. So it's still there. We just kind of throw it out of the way, I guess, because it's understood to be there. All right? Let's look at the last part. Which of these square roots will lie between what number? Okay? Determine which two whole numbers. So we're looking for the actual numbers this time, right? Well, if I look, the square root of 127 is between, if I was to put them on the number line, 127 would be between 121 and, let's fix this. Hold on, I'm sorry. 127. I don't know what this pen is doing. Y'all give me just 1 second. 127 is between 121 and 144, and the square root of 121 is 11, and 144 is 12. So 127 would lie between the numbers of 11 and 12. Okay? All right? The square root of 7, the first perfect square below 7 would be what? What do you think it would be? See if you can answer it in your head real quick. The first square root below that is 4, and the one above it is 9. So it would be between 2 and 3. All right? The square root of 275, the first number to the left of 275, and the first perfect square root to the right of 275 would be, the first one to the left would be, what do you think? 256 and 2, what do you think? 256 and 2, come on, 89. Right, good job. So it's actually between 16 and 17. All right, last one. Pretty big number here, right? So 479. What do you think? Between what? 441 and 484, which is between 21 and 22. Okay, so again, remember, draw that number line. Remember, we started about drawing number lines from 0 all the way to 400, and just place it in there. It's a lot quicker than trying to guess, okay? All right, so that is 1 through 10 for tonight. Look over those problems, kind of go back through them and see if you can understand why we did them. Again, with this one right here, please remember you got your calculator. No big deal. Okay? Come back in a little bit. I'm going to do video 2, which will be problems 11 through 20, and we'll talk about that in just a few minutes. All right? See you in a minute.